Okay, are we ready to get started? Everybody signed in, right? This is usually where I'm handing back your homework. And this is the first time in over a decade that I don't have your homework graded, because something came up that I couldn't avoid. So I will be handing back on Tuesday. I don't think anyone's going to die over it, because we haven't got a quiz coming up next week, so everything should be fine. So that's why I don't have the homework done. Speaking of quiz, look at the date, October 12th. Today is the 28th, so that means 2 weeks from today is the next quiz. Can you believe it? And you can see what chapters is over, because our last quiz was right before we started that chapter 6, continuous data, uniform distribution, normal distribution. And then this week has been data, quantitative, qualitative, data tables, a sum and Countif actually. Matter of fact, here's the things we're talking about today. We're going to review frequency, relative frequency, and percent frequency. We're going to talk about, brand new here, randomness and how important it is. Then we're going to learn how to take a ton of data and break it down into what's called classes. Because what you're looking at is micro amount of data. In real world, you have thousands of pieces of data, so you want to break it into classes. So we're going to talk about how to form classes, class sizes, how to form the class frequencies, relative frequency, and percent frequency for each class. Then with Excel, all of you know how to use sum. I'm just going to review it, but I don't know if you've ever used count, Countif, and count A. And one of these three, count, Countif, or count A, are the key to your Excel part of your homework, which is the largest amount of your homework grade, is that Excel this week. All right, so let's go back to week 5 instructions real quick. Just review what we have to do this week. Due on Tuesday, we have a written assignment, Excel assignment, just those 2. The video, oh my gosh, after Tuesday's class, putting that video together, for some reason Microsoft, I guess, must have did an update, and when I went to open the usual way would I take the video from the phone to the computer, it would not work. Would not work. I mean, I tried and tried and tried. So I thought, okay, I'm gonna go the old-fashioned way, which wouldn't work before. Where you just go to into the folder of the iPhone, click on the video, copy, paste it, right? Well, these videos have been so big, that would never work. And now all of a sudden with this update, that works. So I got the video there, but it took me a while to figure it out. So then I opened up the video editor. That update changed that, and it says no longer available. I had no way to edit the video the way I know how to edit the video. So I had to download a whole different editor, which took forever, and then I had to learn how to use it, had to figure it out. So if anybody watched the last week, Tuesday's lecture, you may have noticed at the end it's kind of screwy. It's because I have no idea what I did. So anyway, that may happen for a couple videos. There's a learning curve on this new software to try to figure it out. And I don't know if it shows what time I got posted, but it was like midnight by the time I got the video posted last Tuesday. When usually it's up there by 4 o'clock. So you can see how much time it took. So anyway, there's the link to the video. It's also posted on Canvas. Speaking of Canvas, let me just look. Don't forget you have an in-class today. What happens if you miss class today and you couldn't be here for the in-class? Can you still hand it in? Yes, but are you subject to a late reduction? What? No. No, if what?
Submit it before next class.
If you, no. Ooh. Yeah. If you submit it before midnight on the day you're absent, then there's no late reduction. But if you submit it the next day, it's 25% off. You submit it the next class, that would be 5 days later. That's 25, 35, 45, 55, that's 60% off, the max 60 at next class. So you want to get it done by midnight. So today, after the class, I post the in-class assignment here, so anybody who's absent will know hopefully to look there. If they get it done by midnight because they weren't here, no late reduction. They don't have anybody to compare with or anything. All right, so now let's go to, we're gonna review. Here we go. We're going to review frequency, relative frequency, percent frequency, because I need you to understand how similar it is to using the same thing with classes. Frequency, relative frequency, percent frequency are very similar when you have classes involved. But here is just, we don't have 1,000 pieces of data. We only have, I don't know, 20 pieces of data there. We've seen it before. It's the hotel, I don't know, randomly picked the guest and said, hey, how was your stay? And there was 5 choices there, from poor all the way up to excellent, and 3 in between. We went ahead then and counted. We put them in order and noticed that the responses are in order, in some kind of order. Now, this could have been excellent all the way down to poor, but you want to put it in some kind of order, whatever the possible responses are. You don't want that to be random. So if you notice, they're going from poor, below average, average, above average, excellent. That order makes sense because each one's better than the one before on the way down. So there's our frequencies. To review how to turn that to relative frequency, you got to take each one of those frequencies and divide by the total number of data. So 2 divided by 20, 3 divided by 20, 5 divided by 20. Leave it in decimal form. Whoop, whoop. And there it is, relative frequency column, the middle one. 0.10, 0.15, 0.25, 0.45, 0.05. If you leave it in decimal, each number divided by the total amount of data, that's relative. Move the decimal 2 places to the right. Put at the top of it percent frequency. You can go ahead and put the percent symbols if you want. That's fine too. But move that decimal 2 places to the right. You now created a percent frequency table. So everybody can tell the difference because you could get a question. I think on the homework you have a question. I believe it's asking you to make a relative frequency table. And there may be another one in your future that's asking you to make a percent frequency table. So make sure you know the difference. That's it. That's it for our review, for those 3. So now, I know we looked at it already on Tuesday, but I want to look at it again. The homework assignment. Hang on, I gotta zoom in here. Now that we just reviewed relative frequency and percent frequency and frequency, let's talk about these problems again. Number 1, I think it was A and B, you have frequencies there. But A says, let's see, how many rookies received a rating of 4 or better? Well, you can count that. How many of the rookies had a rating of 2 or worse? Oh, you can count that. Here we go. B, construct a relative frequency distribution table, and then answer the question, what proportion received a rating of 5? So once you finish your relative frequency table, and it should look like what we just saw, this column right there, you're gonna maybe highlight or circle one of these and put an arrow and say that's the answer to the question. I'm not expecting you to write down any of the questions out of the book. Just make your relative frequency table and answer that one question, and then do A also. You got A, but in B, make your relative frequency table, and then put an arrow or circle or whatever, and put that's the answer to the question, whichever one is the answer. Let's look at one more, or maybe 2 more. I think we're doing number 2 also. There it is. These are we doing, I better look. Yeah. Are we doing number 2?
Yeah.
Oh, hey, stop looking. That was your in class. Thank God I make that so small you can't see it. That would have been close. We all have to start at the same time. So number 2 was 2A only. Let's look at it. So there it is. We have these shirts, I believe. Is that what this is? Shirts? And we have small, medium, large, and extra large. There's how many we have. We go up to A. It says construct a relative frequency table. I'm going to stop right there. We're looking at 2A. There's 4 different sizes of shirts. Small, medium, large, extra large. It says make a relative frequency table. What's the first piece of information we have to gather right now? What calculation to start making the relative frequency table? What do we have to do first? Add them up. That's it. I want to make sure you guys knew that. Because if you don't have the total, you don't know what to divide each one of those numbers by. And once you show the work that you added all 4 of those up, now you're going to use that number. You're going to show me the work that you took 80 divided by that total. Is that 80? Yeah, 80 divided by total. 175 divided by total. 210 divided by. That's the work I'm looking for. Then either highlight or circle, whichever one answers the question. Let's read it. What proportion of sales were for the medium-sized shirt? So when you take 175 divided by the total, whatever that answer is, that's the one you're circling saying answer right there to whatever the question is. The proportion that are of medium that were sold. These are too easy, aren't they? So I'm going to jump to 5 because sometimes 5 gets confusing for people. So here's the deal with 5. Should I make this bigger? Because if I can't see it when I'm over there, maybe you guys can. This says, a recent poll, I got to read it off here. A recent poll of 3,057 individuals were asked, what's the longest vacation you plan to take this summer? Here's the answers. A few days, a few long weekends, 1 week, 2 weeks, and there's a relative frequency table with it. This is backwards. The table's relative frequency already, but the key is they told you how many the total was. So you just have to work it backwards to create a frequency table. You got to take that total
and multiply it by each of those relatives to see how many out of that total belong in each one. And make sure you round appropriately, because once you create your frequency table, they should add up to exactly 3,057 responses. So that's how you know you did a run, by making sure they add up to 3,057. That's number 5. That's the hardest one of the written homework. Everybody knows what to expect there, right? And it's due tomorrow, correct? Saturday? Can't remember. Tomorrow? Saturday? During the game? Tuesday?
Tuesday.
All right, just check. All right, let's see, what's next?
It's just like we did.
We're gonna go back a little bit, backwards, to slide 28. This is chapter 1 PowerPoint this time. All right. I want to use this example to try to define randomness for you, because when it comes to statistics and research, where's that water? When it comes to statistics and research, the key is the process. When let's say somebody's doing research and they apply statistics to a problem and they're submitting it to be published, it's got to go to a bunch of other people who do research. They look it over and they say, hey, was this done correctly? And here's what they're focused on. The process of how the data was gathered is one of the main things they're focused on, to see if there's any possibility there could be bias in the data, which will then say, oh, that's why those results turned out the way they did, because you collected the data this way. That's one of the major mistakes researchers make, is how they collect the data. The key is randomness. Now let me make sure you understand what I mean by randomness. If I have, and I'm going to use this as an example, Hudson Auto does tune-ups, and they want to figure out the average amount of money, or was it the average price or the average, examine 50 customer invoices tune-ups. See the cost of parts rounded to the nearest dollar. So they want to find the amount of money on average spent on parts to the closest dollar. And they're going to pick 50 randomly. But here's the deal. I want you to picture this. I'm pointing right now at filing cabinets. You've been in an office, I got 4 of them here. And each drawer, there's 4 drawers in each of these cabinets. So I got 16 drawers. And if I open them, they're stuffed with invoices for over the last couple of years. And maybe we're only going back a year. Maybe there's 1 year's worth. But they do that many tune-ups. We're only picking 50. The key to randomness is every one of those in all 4 cabinets has to have the exact same equal chance to be one of the 50. Whatever process we decide to use, what will be evaluated is did every one of them have an equal chance to be one of the 50 that we're going to pick to evaluate? Does everybody understand what I'm saying? Now, there's a million different possibilities of processes we could all make up to decide how to randomly pick 50. So I'm gonna show you one. I'm going back when I used to sit in this class, business statistics, and I was taking it, and I was a young person, and Excel was not invented yet. And we had to buy a little thin book on top of our statistics book. We had to buy a little book called a book of numbers, random number book. And it looked just like this. Tell me I opened it. I did. Looked like that, but pages. Pages. Let me make it big. I want you to see all these numbers. Whoop, whoop. Let me get to the top. Okay, so on day that you have a statistics class, you're carrying your stats book and this thin other book, kind of soft cover with it, that has nothing but numbers in it. Because back then we didn't have a computer. Nobody had computers or a phone in your hand or anything like that to be able to generate numbers at random to maybe assign to these. So instead, our professor would say, hey, I'm gonna pick a column, I'm gonna pick the number of digits, and you use that column until you get 50 numbers that will work. And if a number doesn't work, you go to the next one until you have 50 of them. Now let me give you an example. You ready? Let's pretend that we realize there's 999 invoices in these 4 cabinets. And we luckily, while we were putting them in these cabinets, numbered them from 1 to 999. Odds of that are slim. Stay with me though, right? Hypothetically. They're numbered from 1 to 999. And I say to you, hey, we're going to use, I'm making this up, column 5, the last 3 digits of each number in column 5 until we find 50 good numbers. I want to see if you're with me. I don't know what the first number is, but I want you to tell me the first number, and I hope you can say it before I figure it out. I'm going from the left. 1, 2, 3, 4, 5, 3 digits, because look, 999 was 3 digits. We're going from 1 to 999. Says the largest number is 3 digits. We're only using the 3 digits on the right side of the number. What number do you see? I heard it. There it is. I hear it again. 705. Is that what you said?
No.
Huh?
770.
Oh, is it 770? 1, 2, 3, 4. Did I say count of 5? Okay, I'm counting this again. 775? Hang on. Where's my pointer? There it is. 1, 2, 3, 4, 5. No, 705. The sixth one would be 775, but 705. Here I go. That's over here by 999, kind of. Okay, 775. There's one. Tell me the next one I should be picking. Let me get my pointer out of there. Which drawer should I go to now? Which number?
48.
I can't hear you. 48. I'm going over here to the far left side. I'm grabbing number 48. Give me the next one.
569.
Oh, 569. We're using 3 digits. The only reason we did 48 because it said 048. So now we're using 569. I'm looking for 569. There it is. I got it. And you would do this. I'm trying to get to one that's a repeat number or something, or doesn't make sense. But they all make sense. I don't see a repeat number. But in most cases, all of a sudden you get to, oh, hey, look, the random numbers have, where was that 48? Has 048 again. When that happens, you just move on to the next number until you finally get to 50 of them. So it's just moving on. That's how we used to do it. So what happens is we all of the students would have the exact same 50 because we're all using the same column, we're all using the same 3 numbers to the far right. So that's how this works. Now, that's not going to be the case anymore. Again, where are we? Instead, I didn't open it. Let me just get a blank one. Here we go. Equals instead we can just use RAND parenthesis parenthesis, no spaces, nothing between the parentheses, but not even a space. RAND left parenthesis, right parenthesis, and it will generate a number from 0 to 1, and we could just say use the first 3 digits to the right of that decimal. So which one now am I going after? What number? Say it. I heard you. What? No, the far. This time I said the first 3 digits. So 152. By the far right when you write would be 642. The first 3 digits would be 152. So now watch what I'm going to do. I'm just going to put a space in here, and I'm hitting enter. The number changes. It gives you a new random number. 234, 554, 230, 20. Right? 020. So we're going to go for number 20. And if we end up 545, let's pretend we had 545 again. We already got 545. We just move on to another number until we get 50 different ones pulled out of there. Here's my question. Since they're numbered from 1 to 999, did I use a process that you feel every one of them had a fair chance to possibly be one of the 50? Because any number could have came up between 1 and 999, right? I mean, Excel has no bias here. They have no idea even what we're doing. It's just randomly picking a number. So that's another way. Whatever process you use, the key is, and what I need you to get out of this little demonstration is that how important randomness is and what it means. Randomness means, in research, in data collection, that every piece of data in the population, which means all of these invoices, had an equal chance to possibly be selected for the sample. Whatever process is used, each one of them had an equal chance to possibly be part of the sample. That's what randomness is all about. Whatever process you come up with. If we only had, if we had 999 here and I had a way to just throw them in the air and whichever 50 land closest to me, if every one of them could have landed closest to me, that would be another process that's fair. Whatever the process is, the idea is that every one of them have the equal chance to be part of the sample. If there's not that in the selection of data, if the randomness isn't there, for some reason there was like 999 never had a chance, 1 through 10 never had a chance because of whatever the process is. If that happens, then that's called data bias, B-I-A-S. And if it's discovered there's bias in the data, your research does not get published. That's it, period, done, you're over with. That's what other researchers are reviewing before it gets published, to make sure one of the key things is that you had, every piece of data had a fair chance. All right, so there's randomness. Now, let's go to classes. We're going to 16. We're back to chapter 2 PowerPoint. If you're following along, we're going to slide 16. We're gonna take, we're still out, here we are with the invoices. We got our numbers, we pulled them out. How many do we have? 50, right? 1, 2, 3, 4, 5 times 10. We got, there they are, there's the 50. We opened all 50 of them up. We looked at what we spent on parts. Here they are, they're all over the place there. We don't have them in order from smallest to largest yet or anything like that. But there's the 50 pieces of data rounded to the nearest dollar. Every one of them had a chance. But you gotta imagine, you're looking at 1,000 pieces of data. And we're not gonna sit there and keep every piece of individual data as separate data. We're gonna clump groups of data together so that we can analyze it better. So here's how you do it. You form classes. Classes, all right? Now, classes are usually between 5 and 20. And let me show you what a class looks like. You ready? Look at this data now. How many out of those 50 tune-ups was the price between $50 and $59? How many were between 60 and 69? Those ranges that we broke the data into are called classes. So it's a matter of how many classes should we use? And how do you figure out what the range of each class is? Here's the formula to figure out, well, wait, I'm sorry. I want to make sure I gotta say something else first. Yes, between 5 and 20 classes is how many usually you would ever use for classes. And it all depends on how much data you have. If you have a ton of data, you want to be closer to 20 classes. If you only have 50 pieces of data like that, you want to be closer to 5 classes. So the less data, the lower amount of classes you want. The more data, the more classes you want. The key is not to do, it says it right here, where is it? Right there at the bottom. Do not use so many classes that some contain only a few data items. And if you have a class with 0 data items, you probably are using too many classes. So that's a good evaluation. Or if you have classes that only have like 1 piece of data where some of them have hundreds, you may be using too few classes possibly. So there you go. So now, it's an objective point of view as to how many classes, but stick to the rule of thumb. Lower amount of pieces of data, lower classes, a lot more data, bigger classes. Here's the formula to figure out what size every class could be, because when I say size, notice something about these classes. Every one of them are the exact same range from the smallest number to the largest number in each class. 50 to 59, that's a 9. 60 to 69, that's a 9. Every class has to be the exact same size. You cannot vary. They must be exact. I want you to notice another thing. Notice how one class, the first one, ends at 59, but the one after it doesn't start till 60. That's called no overlapping. I'm bringing this up because your assignment's asking you to do your classes as no overlapping. No overlapping is used when discrete data is the data being broken into classes, which, by the way, look at this. Discrete data. It doesn't say $89.50. It doesn't say $52.22. These have all been rounded to the nearest dollar. There's no point anything. So this is discrete data, and that's why our classes don't overlap. But if that was discrete data, let me show you the classes if it was. 50 to 60, 60 to 70, 78. If it's continuous data, you overlap, and you allow the computer to decide which class the data's in. And if you happen to have a 60 in the data, don't worry. The Excel will figure out which class it should be in. Don't worry about it. So if it's continuous data, you overlap like that, but we're using discrete data on our assignment, so you would not overlap. Okay, now I want to show you the assignment for a few minutes because I want to go back and forth because I want you to put it together with the homework you're about to do. Here's your Excel assignment. Matter of fact, should I make it smaller so you can see all the data real quick? Okay, so there's the data. Make sure you realize it goes all the way to column W. And so there's your data. All of these questions have to do with this data up here in the top right. These first few questions are easy. It's asking you, hey, what's the mean of that data? But listen, you gotta use an Excel function equation to answer that question. I don't want you to just put the mean in there. All of these questions, you gotta use Excel function equations, except for when you're entering the classes themselves, which we're gonna get to. The second question says, use an Excel function to tell what the largest piece of data is of that data. The next question says, use an Excel function to tell what the smallest piece of that data is. So you know, we've learned a couple of ones to find the largest. We've learned a couple of Excel functions to find the smallest. So there could be two different answers there, but it doesn't matter whichever one you feel more comfortable using, as long as you're using an Excel function. Now, here's where it gets confusing. I'm gonna stop right there. I'm going back to the PowerPoint because what is this? This is I-19 lines up exactly with this PowerPoint slide. This is one of your hardest homeworks. Just preparing you here. Wait. Where are we? Where is it? Did I lose it? Hang on. Oh, there we go. That cell, whatever it was, I just forgot already, is exactly this formula. This formula determines the size of each class. What should be that spread from one number to the next of each class? You take the largest number of all the data, you subtract the smallest number of all the data, and put parentheses around that, because you've got to do the subtraction before you divide. And then you're dividing by whatever number of classes you decided there should be. If you said, hey, there should be 5 classes, you divide by 5. If there should be 20 classes, you divide by 20. It's however many classes you feel, based on how much data you have, there should be. But for the assignment, I'm telling you how many classes to use. So we're all going to have the same classes, because I'm going to tell you how many. The only reason your classes will be different than another student is if you rounded the wrong way. As long as everybody does appropriate rounding, every one of our classes will be the exact same numbers and the same size. So now, I want to hypothetically pretend, first of all, let's look at this one. Hang on, I do want to show you this one. We said, okay, computer, go find the largest number, 109 out of that data. Okay, computer, go find the smallest number, 52. Now subtract them. Now divide by 6. That's a mistake, by the way. Just ignore it, though. Let's hypothetically say it turns out to be 9.2. 9.2, round it, 9. Make each class 9. Now, where do you start? What number should I start at? And then add 9, add 9, add 9, add 9. But what number should I start at? Look at what the lowest piece of data, the smallest piece of data is. It's 52. So if you want to make your classes kind of look good, maybe start at 50. It's up to you. In real research, you can start at any number. On your assignment, I'm forcing you to start at the number 100. So we're all going to have the same exact numbers in our classes. But in reality, you had a choice what you want to start at. To make it the classes look clean, this particular project, the person said, well, if the smallest piece of data is 52, I'm going to start right there at 50. Add 9, 59. Don't overlap. Next number 60. Add 9, 69. Don't overlap. Next number 70. Add 9, 79. Don't overlap. Next number is 80. Add 9, 89. Let's go to 100. Add 9, 109. Okay, did I do this right? Let's see if the smallest piece of data is going to fit in the first class, and let's see if the largest piece of data is going to fit in the last class. And if that works out, and I don't have any classes with zeros, I probably did this perfect. 50 through 59 had 2 in it, 60 through 69 had 13, 16, 7, 7. The very last class, 100 through 109, had 5. The largest number is 109. This ended at 109, so it fits. The smallest number is 52. It fit between 50 and 59. It fits. We did this right. Those are all the things in checks and balances when you're forming classes. Did I have the right? We could have went with 5 instead of 6. Each class would have been different then. And maybe it would still work out, and that's fine. 5 could have worked, 6 could have worked. But if we went to 7 and 8, we may have had some classes with zeros. And that's when you go, okay, I've got too many classes. I got to go back down to 6 or 5 or something like that. And one person could have 5, and one person have 6, and they're both right. But for the homework, let me show you. I'm forcing you to start at 100. I'm forcing you to use, I can't remember how many classes. Hang on, we'll look. So it says, right here in this cell, it says, use the equation from Chapter 2's PowerPoint to determine the size of each class if you were to create 6 of them, here it is. You're gonna take, and I want you to use cell locations, not numbers. Let me repeat that. When you write this equation for that cell, I-19, use cell locations. For example, find the cell location that you've already found the largest number, minus the cell location where you already found the smallest number, divided by 6. But put parentheses around that subtraction. That has to happen first before you divide. And then whatever that turns out to be, you're going to round that appropriately and add it to the number 100, right there. 100 plus, and I know it's going to be 200 and something. I left question marks there for you to finish. Now, I want to hypothetically pick a number that I know that it will not be the spread of each one, but I want to show you how to do this. 100 and, give me a number between 100 and 150, any number. 139, here we go. But, hang on, you know what? This will be easier for you. Because I gotta do that. Ready? So you just discovered that the spread of each class should be 140. Even though that's not true, this is hypothetical. I'm gonna show you how to make the classes. You just jump on here and you go, okay, 140 plus 100, that's 240. There you go. Now go to the next one. Okay, there's no overlapping because we have discrete data. So this is gonna be 241. And this, and I add 140 to it, so 241 plus 140 makes 381, right? Is that right? Okay, got that one, no overlapping. Help me out, what's this first number then right here?
With the wrong answer.
Do I have a wrong answer? What's 241 plus 140?
393.
Wait a minute. Wait, we're adding 140. What is 241 plus 140? Is it 181, yes? It's gotta be. 381, excuse me. So this, what is this one starting at? If that one left off at 381? 382 plus, whoops, 82 plus 140. What do we got? Huh? 422? Is that right? Then what are we starting out on this one now? What will be the first number of this class? Can't hear you. 423, very good. 423, add 140. We have 563, and you go like that. I'd get to the end, and I'd go, okay, I can see up above here what my smallest piece of data is, and look, it fits in the first class. I will be able to see up here what the largest piece of data is, and look, it fits in the last class. And then when I get through with this project down here in the next row, down here below, I'll be able to see if any of my classes have a 0, so I know I used the right amount of classes. They won't, because I'm forcing you to use 6 classes. Go ahead.
You were adding 140 to 382.
382 plus 140 would be, oh, I'm sorry, 5, thank you, 522, right?
Yes.
Thank you, hang on. 522, there we go. Now I got, what will this then be? 520, 523. All right, then add 140, so that's 623, 663, hang on, 663, and so on. How's that? Is that better? And then we would look and see. But this is the part you gotta manually enter. As I was manually entering each one of those classes, adding the 140, again, this is hypothetical, yours won't be 140. Adding the 140, it automatically switched the numbers in each of the lines below that are not highlighted, because I have it all set up that way. Once you enter them in these highlighted cells, down below, they'll all match. And below this too, let me keep going. And there they are again. They're also being copied right here as you enter them. Okay, so everybody knows how to figure out the largest, the mean, the largest number, the smallest number, the spread or range of each class in that calculation right there. And then here you manually enter the classes. Now, here we are. E30. Row 30 is where the points are. This is it. This is the main part of today's lecture. All right? You have to come up with some Excel functions. How many of them? How many classes we got? 6 of them? 1, 2, 3, 4, 5, 6 Excel functions that do the following. You're telling Excel, go up and look at that data and tell me how many of them are between, in this case, 100 and 240. You're over here, you're going, hey, Excel, now go up and look at the data. Tell me how many are between 241 and 381. You have to write Excel equations that will go up and count for you how many are in each one of the classes. And when you get done with these Excel functions, I have this set up right there to add all the results. And here's your check and balance. If that number right there, what is that? R30. If R30 equals, and you go count how many pieces of data you have, and those two, that number equals exactly the amount of pieces of data you have, odds are you probably did that row 30 correctly. There's your check and balance. You probably did row 30 correctly if that equals the number of pieces of data. You go up there and count them. All right, that's the key. Now, how do you write equations to count data? Are you ready? Where is it? We're going to learn about count, count if, count A. Let me start with, hang on, let me start up here with count. Is this count? No, sum. Oh, I forgot, we got to review sum. You all have used sum before, I think. So you use equals, SUM, and give it a range, and it will add all the numbers together. That's what sum means, is to add. So in this case, it says equals, SUM, B8 to B21. Well, B8 to 21, but look, there's letters there. It will ignore the EE. It will ignore the AB and the AB up here, and it will just add the numbers for you. And the total there, if you add all those numbers, is 3,321. That's what sum does. Count. Count goes and adds up all the cells. It doesn't add them, I'm sorry. Counts all the cells that have numbers in them. Let me repeat that. It will say, okay, here's a whole range of cells. Excel says, I'm bringing back the number of them that have numbers in it. So it says 11, but we know there's more than 11 cells here. What it's ignoring is that AB, that EE, and that AB. So there must be 14 here because it has to ignore 3 of them. And it comes back and says there's 11 cells with numbers. All right, now here's another one. Count A equals COUNTA, what is that, B8 to B21. Now, this count A doesn't count how many cells have just numbers. It counts how many cells in that range have anything in it, any value, letter or number. So instead of 11, it should come up with 14. And there it is, 14. Because count A counts, by the way, don't let me forget this, hang on. Right here on page 16 from your book, down at, where is it? Oh, it's down here. On page 16 at the bottom, there's another example and discussion about count and count A. And then also, where is it? Top of page 17. Top of page 17, you have more discussion about count A, count, and count if, which we're about to count. C talks about count if right there. So it's right there. So if you want another source, because we're about to learn count if. This is where I start to lose some people. I want to make sure you're with me. Count if. Oh, hey, hang on. Look at the equation up here. Equals, count if, parenthesis, B8 colon B21, comma, quotation mark, greater than symbol, 30, quotation mark, parenthesis. You're telling Excel, because you use the word if, that, hey, Excel, go to that range of cells and count, but because the if is there, look at what's after the comma and only count what's between those quotations, which says greater than 30. So it's going to bring back however many numbers happen to be greater than 30. Now, I'm going to pretend I don't see that there's 8, and I'm going to count them. 23 is not greater than 30, so 43, 1, 2, 3, 4, 5, 6, 7, 8. That's it. There's 8 of them greater than 30. Let's see. Let's try. I'm going to change it up. I'll just do another one. Equals, count, if, parenthesis, the range of data, comma, now the criteria. Watch what I gotta do. I gotta put the quotation. This time I'm gonna do less than, and let's do 30. Let's see how many are less than 30. Now I gotta do the quotation. So I just typed count if B8 through B dot dot B21 comma, quotation mark, less than symbol, 30, quotation mark, parenthesis. So let's see, there were 14 pieces of data. It says there was 8 greater than 30, so we should get back a 6. You agree? For 14, let's take a look. 3, what? That's because not all of them have numbers. 3 of them don't have numbers. So really, there's only 11 cells with data. And if 8 of them are greater than 30, 8 plus 3 make 11 would be less than 30. Because the other 3 have letters in them and they don't count. Trying to think of another one here. Anyway, you know how to use COUNTIF, but here now, you ready? Here's an example of using COUNTIF between 2 numbers. Equals COUNTIF B8 dot dot B21 comma, quotation greater than 20, quotation, parenthesis, minus COUNTIF, parenthesis, B8 dot dot B21 comma, quotation greater than, does that say 54? 54, quotation, parenthesis. You're telling Excel, go count all the numbers that are greater than 20, and there's gonna be a bunch of them. Go count all the numbers that are greater than 54, which there's some also, but less than there are greater than 20, because 20 gets to count the ones between 20 and 54, and now subtract the ones, however many there are greater than 20, minus however many there are greater than 54, that's how many are between 20 and 54. In this case, there's 5. Is the light bulb turning on for anyone? No one? No one?
The video will be helpful.
Let's do another one. Let's say I want to find how many numbers are between 50 and 400. How about, or 50 and 1,000? Ready? We want to find out how many numbers. All I gotta do is look at this. I don't even, you know what? I'm just gonna make it easy on myself. What did I say, 50 and 100? I'm gonna change that to 50. Whoops. Now, and I'm gonna change this one to 100. Oh, I'm sorry, I said 400, didn't I? 400. Before I hit enter, let's see how many numbers are above 50. So I'm looking at all the numbers here above 50. No. 1, 2, 3, 4, 5, 6. There were 6 numbers above 50. There should be less of them above 400, less above 400 because 400 is a lot bigger number than 50. It's going to exclude all the ones between 50 and 400. So now count the ones above 400. There's 432, there's 1. 871, there's 2. Oh, that's, is it going to count that 400 as above? No, it's not above, so we can't count that one. We only have 2 still. 3. So if it doesn't count that 400, because I didn't say greater than equal, which I will switch it in a second, I will put equal to see if it does count that 400. If it doesn't count that 400, because it's not greater than 400, our answer should be there's only 3 numbers between 50 and 400. But if it counts that 400, this now would become a 4, and the answer would be 2. So are we going to get a 3 or a 2? Is it counting the 400 or not? No?
Because it's a 7, not a 6.
Ready? Oh, this is a 7?
Yeah.
Oh, man. So 7 minus 3, because it's a 4. If it's 7 minus 4, it'd be a 3. It's not counting the 400. But watch what I'm going to do now. I'm putting greater than, and I'm adding the symbol equals right next to it. That's telling Excel now, hey, I want however many numbers are 400 and above. So this time there'll be, instead of 3, there'll be 4. So 7 minus 4 is going to equal 3 because I put that equal sign. There it is, 3. So you can add an equal sign with the greater than or less than depending on what the situation is. Maybe you're telling them which one. If we have continuous data and we have overlapping like this,
maybe you're telling which one to put the 60 in by adding the equal sign on one of the equations. So you have to decide. By the way, we don't have continuous, we have discrete data. Let's talk about it again. Let me go back to the homework, because this is the hardest part, but this is why all the points are right here. So here we go. I'm right there. I'm not going to give you the answer here, but here's what you should be writing. This is, again, this is row 30. I'm in E30, and you, right there in that cell, you should be writing an equation that will find how many of the pieces of that data up at the top are between 100 and 240. The only reason we're using 240 is because we hypothetically said the range was 140 for each one. But if that were the class, you would be writing an equation to find how many between 100 and 240. And then here, you would write another equation to find how many are between 241 and 381, and so on, and so on, and there's 6 of them there. If these are worth, 7 points apiece, 6 times 7, that's 42 points of your homework just in this row. And then you would come to the end, and there'll be a total right there in R30, and if that number equals the total number of pieces of data up there that you can count real quick, then you know you probably did it right. Now, here's the easy part, is down here, finishing this off with either relative frequency or percent frequency, but let me go back to the PowerPoint so you can see it. So let's go back to we're going back to the tune-ups. We pulled out 50 random invoices. We went ahead and found the amount spent on parts for each tune-up. We broke it into 6 classes. There's our 6 classes, there's our frequency. Now, exactly the same way you found the relative frequency and the percent frequency on regular data that are not in classes, you do it the same way here. 2 divided by 50, 13 divided by 50, 16 divided by 50, and so on and so on. 0.04, 0.26, 0.32, 0.14. Move the decimal 2 places to the right, put at the top percent frequency, and here, and I'm accepting if you want to put percent symbols next to each one, move the decimal 2 places to the right, you got 4%, 26%, 32%, 14%, and so on. So once you find your classes and get the frequency, convert it to a relative frequency, and a percent frequency is just like we reviewed from chapter 1 with regular data. Go ahead.
So for percent frequency, I just multiply the relative frequency by
The symbol.
by 100.
Yeah, and that moves the decimal 2 places to the right.
Yeah, it came up as a decimal. Do I have to, I got 17.85. I have to put like 7,
You gotta do 4. You gotta go 4 digits. So if you got 0.1785, you would move the decimal 2 places, 17.85%.
Okay, so I have to add the percent.
You don't have to add the percent symbol as long as the title up top says percent frequency. If it says it at the top, you don't have to add the percent symbols, but a lot of people add them, and I never took off any points for it. Okay? All right. Count if we did that. How many classes, book page. We have an in-class assignment. How are we doing on time? Oh, we're ahead of schedule, aren't we?
Yeah,
Ahead of
let's do it
schedule.
right now.
Okay, let me tell you, hang on, I didn't plan on a life lesson today at all. No life lesson today, but something happened on my drive in. An old friend of mine called and was panicked, saying life is just throwing so much stuff at her. She said she has so many problems going on and on. She can't believe all this is happening, and wanted to figure out, and so this is what I came up with as wanting to know, how do I turn my life around so I'm not getting hit with problems? She's saying, I will solve one problem and 2 more appear at the moment I get that one solved. Anybody have this happen in their life? Do you know what I'm talking about, where problems come one after another? Well, I used to have that happen, and then I tried to figure out, how do I get my life so I don't have problems come all the time? And this is what I did. So I went ahead and typed this out on text while I'm driving, and kind of putting it on there was crazy, right? I know, but you gotta remember, no. I'm in a traffic jam going only 12 miles an hour though. So give me that at least. And I have a little sensor that tells me to hit the brakes when I get too close to the car in front of me. So, all right. So I said, the reason you're getting problem after problem after, you're getting 3 every time you solve 1 is because life is testing all of us. Life is testing all of us. Look how old I am. I am telling you, life is testing you all the time. That's what it is. Temptation to do wrong compared to doing right is all around us. Be smart. Choose right over wrong, and life rewards you.
It takes time. Once you start saying, okay, I have a decision here, here's wrong, here's right, I'm choosing right this time. Okay, I have another decision, here's right, here's wrong, I'm choosing right this time. It takes time, 6 months, a year, and now you've got all your problems solved, and they don't start coming so fast. You'll go for a while with no problems at all. Don't get me wrong, you will always have problems. But they're so far between once you start living your life differently. You start realizing that every decision, every minute you're making, let me make sure you understand what I'm saying. Every single second, your brain's making an unconscious and sometimes conscious decision. You're making a decision to breathe. You're making a decision to sit. You're making a decision to stay here. Every minute you're making decisions. And once you start recognizing that every decision has a wrong and a right, and you go, wait, which one's right? And you head towards the right, life rewards you. Rewards you. Instead of causing you problems, all of a sudden you have good luck. What the heck's going on? I got more good luck. That's how life is. I'm an old man. I'm telling you from experience. That's exactly how life is.
Let's take the road.
That's what she said. Anyway, okay, let's do the end class. You ready? We're getting out a little early. All right.
Gosh, I gotta make this bigger. I can barely see it. Hang on, we're gonna fit this all on here? Here we go. You gotta see there we go. Oh, no, I'm too big now.
We got a copy of the chart down or no?
Oh,
We got a copy of the chart?
yeah, wait.